In your notebooks, please jot down the title, Note 6.1, Operations with Functions. Bless you. Write down today's date and day, 1/7/2020. Welcome to the new decade. It is Tuesday. Jot that down. And we're going to start by doing like a warm-up exercise. I give you two functions right here, the f of x function and the g of x function, right? Today we're going to be doing something, operations on functions. So this is what we know so far, that f of x is just the name of this machine that of course you could have inputs and outputs to. G of x is just the name of this machine, of course. So we should already know about functions. We should already know that f of x is the name, g of x is the name. And we also should know about function notation. Right here it says find g of 3. It's not g times 3, it's g of 3. So what that really means is for you to take the 3 and plug it into the g of x function. So 3 is the input, you need to find the output. So you're going to take the 3 and plug it right into your g of x function, which is here. So you're going to plug in the 3 right in there. Okay? I want to pause it, give you a couple of minutes to actually find those answers, and then we'll go over the work and show you how you get the correct answer. Go for it. Try it. So I hope you guys got the correct answers. I think it was -10 for number 1 and 11 for number 2. But let's really explain how we get those answers. Again, this is the notation saying go to your g of x function and plug in 3. So go to your g of x function, here it is, and plug in 3 right in there. So the key is to rewrite it, but instead of the x, put parentheses where you're going to plug in your 3. So let's rewrite it. You're going to write -4x plus 2. But instead of x, we put the parentheses, and instead of x, we're going to plug in the 3. So take the 3, put it right there, and now it's just simple math. What's -4 times 3? That's -12. And what's -12 plus 2? That's 10. -10. So there's your answer for number 1. Now let's go to number 2. Find f of -3. Go to f of x function, plug in a -3. Okay. So take the -3, put it right into the f of x function. So let's start by rewriting this guy as 2 parentheses squared minus 7. Let's write that out. 2 parentheses squared minus 7. And we're going to be plugging in the -3 right in there. So right into the parentheses, we're going to plug in this -3. And now let's do the math. You have multiplication, you have exponents, you have subtraction. According to PEMDAS, the correct order of operations, you're going to do exponents first. So that's -3 in parentheses squared. So -3 times -3 is +9. Then bring down the -7. 2 times 9 is 18. 18 minus 7 is 11. So those are your two answers. We should know this. It's a review from semester 1. What we're going to be doing today is different operations on functions. So instead of me telling you, oh, plug in a -3 right here, or plug in a +3 right here, instead of me saying that, I want to tell you, add your f of x function with your g of x function, or subtract your f of x function with your g of x function, or multiply your f of x function with your g of x function. So there's different things that we're going to be doing, but we're going to be doing operations with these functions. So just to let you know that all this comes from the book, check it out. This is page 385 from our book. If you want to look at it in your book, it's on page 385. But like I said, we're going to be adding, subtracting, multiplying, and dividing different functions, f of x and g of x, q of x and r of x. It depends what I give you. So on the example here, they give you the f of x being 2x and g of x being the binomial -x plus 5. And they ask you to do different things. So there's, of course, notation for it. This is the notation for adding your f function with your g function. So this is really saying to add f of x with g of x. All right, so right here it reads f plus g of x, but in reality what that means is to simply take whatever your f of x function is, write it here, put a plus sign, write your g of x function there, and then combine like terms. That's what it means, right? So in the book, it shows you that your f of x function is 2x. There's the plus sign, and your g of x function, the binomial negative x plus 5, you write it in parentheses, and then you combine like terms. So since the plus sign doesn't change anything, you don't have to distribute a plus sign. You could just ignore the parentheses and combine like terms. So 2x minus x, that'll be a 1x, and the 5 is also left over, so it's 1x plus 5, your answer. There it is. It's 1x plus 5. So we're going to be doing these different operations with different functions. This is really saying to take your f of x function and subtract your g of x function from it. So right here it'd be definitely a great idea to use parentheses. So what does f minus g of x mean? It means that you're going to take your f of x function and subtract your g of x function. So when you plug in, you have your f of x function here, 2x. You have your minus sign. You have your g of x function here. Now because you have parentheses here, you're going to have to distribute that minus sign. So that minus sign really becomes a plus right there and becomes a minus right there. So this ends up being a positive x. So 2x plus that positive x will be 3x. This ends up being a minus 5. So your final answer will be 3x minus 5. So we're not simply plugging in numbers into f of x or g of x anymore. Now we're actually adding the f of x with the g of x. We're actually subtracting f of x with g of x. We're actually multiplying, right? This is the notation for multiplying, f times g of x. So take your f of x function and multiply it with your g of x function. F of x in this case we said was 2x, and g of x was the binomial x minus 5. So I'm actually showing f of x times the g of x. Of course you're going to distribute, so what's the answer here going to be? Negative 2x squared, what else? Plus 10x. There you go, negative 2x squared plus 10x. So this is all in the book, guys. They're even going to ask you to divide. This is the notation, f divided by g of x, right? What does this mean? That you're going to take your f of x function and divide it by your g of x function. So we said f of x divided by g of x. F of x is the 2x, and the g of x function was the binomial negative x plus 5. So there's nothing to do here. Sometimes you might have to do long division or synthetic division, but right here there's nothing to do, nothing to cancel, it's all good. The only detail is if you ever have a fraction with a variable in the denominator, you want to state whatever value it could not be, whatever value would mess it up. What number would mess it up right here? What number right here would mess up this whole entire answer? You can't divide by 0. So what number would make it a 0 in the denominator? 5, right? If you have a minus 5 plus 5, you get 0 in the denominator. That would make it undefined. Are you with me? Yeah. So whenever you get an answer that's a fraction with a variable in the denominator, you also have to state what it can't be. Okay? So this is your answer, but you also have to say x cannot be 5, because if this were a 5, it would be a negative 5, which would cancel out with that 5, which would give you 0 in the denominator, which would make it undefined. Anyway, we're going to have a section of the homework that asks us to add f of x with g of x, subtract f of x with g of x, multiply f of x and g of x, and divide f of x and g of x. Of course, there's going to be more. We do have those examples right here on that same page. They give you a different f of x function, a different g of x function, and they show you that they're adding them. You just add them, combine like terms, or subtracting them where you distribute the minus sign. So the book is a great resource to learn, right? As a matter of fact, I don't remember everything in math. Every time I teach a lesson, before teaching it, I go through the book and look at the examples and relearn everything. So there's more examples on that same page where you're multiplying the f of x function with the g of x function. This is just a notation, but it boils down to f of x times g of x. So you write your f of x, you write your g of x, and you multiply. So you'd have to distribute and combine like terms. Also, f divided by g of x. Again, it's just the f of x divided by the g of x. Plug in the f of x function, which is a quadratic trinomial, divided by a linear binomial. And of course, state whatever your x cannot be. If this were a 4/3, the 3's would cancel. You'd have 4 minus 4, which would be 0 in the denominator, which you cannot have. Okay, so there is more to it than that. I'm also going to give you, and this is again in your notebook, I'm going to give you a f of x function and a g of x function, and this looks like a multiplication problem, but it's not. It's not a multiplication dot. It's actually an open circle. This is called fog notation. Fog notation. Now, what do I mean by fog notation? It's really saying that you're going to plug in your g of x function into your f of x function. So whenever you see this notation, it really means f of g of x. Let me repeat that. When you see this notation, it really means f of g of x. Now, what the heck does that mean? Well, we're already used to having f of 5. If I had f of 5, what would I do? Plug in 5. But there is no number 5 right here. It says g of x. So what I need to do is actually take my g of x function and plug it into my f of x function. Okay, so I'm going to take the g of x function, which is really this machine right here, and I'm going to plug it into my f of x function. So I'm really going to be taking the 4a, that's really my g of x. I'm going to be plugging it in right there, which means that I'm going to plug in 4a into my f of x function. So I'm really plugging in the 4a right here into the a of my f of x function, which would mean 2 times the 4a that I'm plugging in minus 5. 2 times 4a minus 5, which would give you finally the answer 8a minus 5. I know that's kind of confusing because it's the first time you've seen it. Again, we're no longer just plugging in a number into the f of x function. Now we're actually plugging in variable expressions. We're plugging one function into another function. And it even gets more fun than that. I might tell you f of g of 5 or something like that, which would mean that you plug in 5 into the g, get an answer, and then plug in that answer into the f. I know you're thinking, fun stuff. It's hard to believe that you're not paying admission for this, right? Let's move on. Here's the worksheet that we're going to be doing. Let's do a couple of these together so nobody's lost. So we're doing 1 through 19 odd, but there's actually some odd numbers that are missing. Don't worry about them, right? I deleted some on purpose. So notice we have 1, we have 3, there is no 5 or 7, right? And we also add a couple of even questions, 10, 16, and 18. So we're doing 1 through 19 odd, and we're also adding on 10, 16, and 18. So you might need to rewrite these in your notebooks. I mean, look at number 1. They want you to do so many things. It's like 4 questions in one. They want you to do f plus g of x, which means to take your f of x function and add it with your g of x function, get an answer. And then they want you to subtract your f of x function with your g of x function. Then they want you to multiply your f of x function with your g of x function. Then they want you to divide f of x with g of x. So here's your f of x, here's your g of x. Let's do each one of these on number 1. So let's do the notation, f of x plus g of x. Now you could write it like this, or you could already jump right into it and say that that really means f of x plus g of x. Let me put the plus in black right there. So what is my f of x function? What's the machine that I call f of x? 2x plus 1. There you go, 2x plus 1. So let's write that down, 2x plus 1. And I am going to add it with my g of x function. What's my g of x function? X minus 3. See, nice and easy. Now, normally we would put parentheses, right? Check it out, let me show you. Normally we'd put parentheses here and parentheses there, but there's nothing to distribute, right? There's nothing to distribute out here. There's a plus sign right here, and if you distribute a plus sign, nothing changes. So it's kind of pointless to put the parentheses. You could jump right into combining like terms. Whoops, that got ugly. Sorry. So let's combine like terms. We have a 2x that we're going to combine with a positive x. That'll be 3x. We have a positive 1 that we're going to combine with a negative 3. That's going to be a negative 2. And there's your answer, 3x minus 2. That's the first answer of the 4. And you could put the notation, the original notation that they had up here, f plus g of x. That equals, I didn't put space for the equals, that equals 3x minus 2. So now let's do f minus g of x. Okay, so what does that mean? That really means your f of x function minus your g of x function. And again, my f of x function is 2x plus 1. And then I have a minus sign right here. Now, right here, I better use parentheses. when I plug in my g of x function. Why is that? Because a minus sign will change things. So we need to really put that minus sign on the whole g of x function, which is x minus 3. So let's put the x minus 3 in parentheses. You see, on the plus one, we didn't use parentheses because distributing a plus sign doesn't change anything. But a minus sign, when you distribute it, it will change it. So let's put in parentheses, let's distribute. I really will have 2x plus 1 minus x plus 3. When you distribute that minus sign to both, it changes the signs. So now we combine like terms. 2x, take away 1x, that's 1x. 1 plus 3 is 4. So there's your answer to f minus g of x. F minus g of x really does equal x plus 4. And that's the second answer of the 4 that they're asking us to do. The next thing they want us to do is f times g of x. F times g of x. That really means to multiply your f of x with your g of x. So what is f of x? It's 2x plus 1, put in parentheses, and then your g of x, that's x minus 3, put in parentheses. Now we really have a binomial times a binomial, which means we're going to be distributing right here. So let's distribute 2x times x, 2x squared. 2x times negative 3 is negative 6x. 1 times x is positive 1x. 1 times negative 3 is negative 3. Combine the middle terms, the negative 6x with the positive 1x, you get a negative 5x. So your original f times g of x, that really is the answer, 2x squared minus 5x minus 3. That's your f times g of x answer right there. And last but not least, we need to divide the f by the g. So I want to do this over here. You guys probably ran out of space already. Do it in your notebook if you need to. We're going to do the f of x divided by the g of x. So the f of x is 2x plus 1, and the g of x is x minus 3. And there's nothing to cancel out. You can't cancel out the x's because there's a plus sign and a minus sign. Sometimes you'll be able to factor and then cancel things out, but right here there's nothing to do. So that's your answer. But x cannot be what?
3.
X cannot be 3. That's your total complete answer right there. The fraction 2x plus 1 over x minus 3, but x cannot be 3. Why? Because if it were a 3, it would make it undefined. So those are the 4 answers. If you check the back of your worksheet, those are the 4 answers that you're going to see for number 1. Just do one more, number 3, and then we move on to the other fun stuff. What do I mean by fun stuff? It's in fog notation. Okay, so whenever you see this little circle, it's not multiply. It really means to take the h of x function and plug it inside the g of x function. All right. Now I did make a typo right here. It says right here which is incorrect. So let's change this. Change that f to an h. There should be an h right there. Not. Let me see if I can do it. Oh yeah, I'll paint this part white so you can't see the f anymore. So it should read h of x that's going to be plugged inside the g of x function. Okay. So what this really means is for you to take your h of x function and plug it inside your g of x function. So which one would you guys like to do in this section? 9? All right. So let's plug in, and let's actually write it like this. H of g of x. And they're also going to want us to do the opposite one, right? G of h of x. Okay, so let's do this one first. Let's plug in our g function into our h function. So what's our g function really? Negative 8x, right? And I need to plug that where?
Inside of h.
Inside the h, right in there. Okay, that's the direct reasoning or what this is telling us to do. So of course, whenever, like if you had a 5 right here, what would you do? You'd plug in 5 into the h of x function. And how would you do that? If I had a 5 right here, you would start by rewriting it 2x plus 3, and you'd plug in a 5 right here if it said h of 5. But it doesn't say h of 5, it says h of gx. So what is gx? It's negative 8x. Let's plug in that negative 8x right in there. And then we do the math. What's 2 times negative 8x? And then we bring down the plus 3. And there's nothing to do. That's your answer right there. H of g of x really is negative 16x plus 3. And now let's do the other one. Let's plug in h into our g. Okay? So now we're going to go backwards. We're going to plug in this binomial 2x plus 3 into the x on the g of x function. So again, if I had g of 2, let's say g of 2, what would I do? I would rewrite this and plug in a 2. I would write negative 8 parenthesis, and I would plug in my 2 right there. But it doesn't say g of 2. It says g of h of x. So we're actually plugging in the h of x, the binomial 2x plus 3, right into those parentheses, right into that x position. So let's put that binomial 2x plus 3 right in there. And now to simplify, what do? Somebody said it. What do? Distribute. So negative 8 times 2x is negative 16x. Negative 8 times 3 is negative 24. And we're done. That's our answer right there. Pretty fun, right? G of h of x is negative 16x minus 24. Does it get funner than that? Yes, it does. Check out this last section. This last section, I actually give you 3 functions. I give you a f of x, a g of x, and a h of x. And not only do I tell you to plug in one into the other, but I tell you to plug in an actual number first, and then you keep plugging in. So let's think about parentheses and how they work. Parentheses tell you to zoom in and do whatever math you can on the inside of the parentheses, right? So if I'm doing number 14, what I need to do is zoom in and start with that 1. And where do I plug in the 1? Into the g function. And when I plug it in, I get an answer. And once I get an answer, that'll be an actual number. And then you take that number and plug it into your f function. Does that make sense? Now, we aren't doing 14 on the homework, so pick one from the homework.
15.
15? All right, so let's do 15. So on 15, we're going to not use the f. We're going to be using the g of x function and the h of x function. So let's begin by zooming in and plugging in the negative 2 into what? Plugging in negative 2 into what? Into the h. And as you could see right here, the h is x plus 4. So when I write my h, which is really x plus 4, I need to plug in that negative 2 right in there. And when I plug it in, what do I get? I get 2. So let's actually keep track by staying organized. H of negative 2 equals that, which will give us the answer 2 you guys just said, right? Again, this is just the notation, me plugging in negative 2 into the h. There it is. H of negative 2, plug it in, we get 2. So we know that h of negative 2 really is the answer 2. So instead of this, what do I really have right there? A what? A 2. Bless you. So what we really have is g of 2. And now let's actually find g of 2. So g of 2 is, go to your g function, plug in 2. Here's our g function, which is 5x. So I really have a 5 times plug in 2. So what's your final answer going to be? 10. So the answer is 10. The answer to what? To g of h of negative 2. So there's your answer. G of h of negative 2 is really positive 10. Where did I get 5? Well, yeah. You start with plugging in negative 2 into your h. So here's your h. Plug in a negative 2, you're going to have negative 2 plus 4. That's positive 2, right? So h of negative 2 really is positive 2. So this right here is really a positive 2. Then you plug in your 2 into your g of x function. G of x is really 5x. So you really have 5 times, but we're actually plugging in that 2. So 5 times 2 is 10. I hope that makes sense. So we have the rest of the period to work on the rest of these questions. We're not doing 20 or 21. We're stopping on 19. We're doing the odd ones, and we're also throwing in 10, 16, and 18. Why? Because they're fun. We'll have more time to work on this tomorrow, but this video is already long enough. Check your answers on the back of the worksheet.